forever. Okay? Alright, so let's have a look. We need a little bit of a formula. Not very new. It's a formula that's going to be very similar to something we did last week for the GP. So you remember for the GP we had Sn equals A, 1 minus or n over 1 minus or. You remember this formula? Yeah. So now let's see what happens if the n is infinity. So we have a sequence A plus AR plus AR squared, but this time it continues. It doesn't stop. So F infinity, what will that equal? Well, Sn equals A 1 minus or n over 1 minus or. So if you want S infinity, that would be A 1 minus or infinity over 1 minus or. Now this one here, what does that equal? Well, you might think it's infinity, and most of the time that's true. For example, 2 power infinity, that's infinity. Because you're going to have 2 power 1 is 2, then 4, then 8, then 16, then 32, and so on. But it's interesting if the or is between minus 1 and 1. So if you had 0.5 power infinity, that's not infinity, that's actually 0. Because what's happening is you have 2 power a big number. That's equal to 1 over 2 power a big number. That's 1 over a big number, which is a small number. So when we have a number like 0.5 to a power like infinity, we get 0. So we have our formula, S infinity is A over 1 minus or. However, we must say that or is between minus 1 and 1. If it's not, then the answer will be infinity. So if we want to make it convergent, we need this, or to be between minus 1 and 1. So this is our first formula for today. If you write this down, we'll have a look at an example. No, but it's good for your brain, help it grow, if you see and write things like this, you know. Personal development. Yeah.
What do you mean by big?
Huh? What do I mean by big?
I know what big means.
Yeah, okay, yeah.
What do you mean by big?
I'm deliberately not being clear here. When I write big, I just mean 2 to a big power, a big number. Let me just discard that. Okay. Do we have this? Watch it. Has to be. It can't even equal 1. It has to be between minus 1 and 1. Can I continue? Yep. Oh, come on. I'll give you one more sip of coffee. Maybe 2. Okay, let's have a look at an example now. So our first example, we want to calculate pull the door open, not push. Yes? What happened to you, Starry? Huh? Missed the bus?
Yeah.
Okay, let's have a look at this one. 3 minus 3 over 2 plus 3/4 minus etc., 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 and forever. What's the A here?
3.
3. And the or?
Minus 1 over 2.
Minus a half. Yep. So using my new formula, the limit here is A over 1 minus or, 3 over 1 minus minus a half, 3 over 3 over 2, which is 2. Okay, write this down, and then I want to show you this in Excel. Yeah? Got this? Okay. Excel now. Where's it gone? Here it is. Loading. I dropped my laptop on the ground earlier today, so nothing happened. It still works. You try dropping your MacBook Pro and see if it still works. Right, U and then S. So what was the first term? It was 3, and the next term was minus 3 over 2. So that's minus 1.5. And the next term was 3 over 4, and so on and so on and so on. So let's add them up. So this is S1. That's just going to be 3. This is S2. So this is where we add the first one and the second one. So 3 and 1 minus 1.5 makes 1.5. What would the next one be? S3. 2.25. Okay. Let's pull this down here. So what did I say the limit should be when you add them all up? 2. So let's continue the sequence to a big number. Let's say like 100.
Why does it go up
Because the plus and the minus is making it kind of alternate between the two. Let's go to a large number like 100 terms. So can you see very quickly it reaches the 2. It's not technically at 2, just very close to it, yeah?
We said that the limit is 2.
Yeah.
But it still goes above 2.
No, what I just said, it's not technically at 2, it's just very close to 2.
Okay.
So the program has rounded it to 2, but really it's more like a number like this. Yeah? Okay. Anyways, that's the first one. Yeah. The half is the or, and the way to get that, you take 2 terms and you just divide them and you'll get the half. So you take 2 neighbours. And the A is always the first term. Okay, let's look at a different type of limit problem now. Can I scroll down? Yeah. Here's one we saw last week. For example, Tn equals 4 minus 3 over Tn minus 1. What's the name of this type of sequence? Do you remember? Yeah, what's it called? Something sequence. A what sequence?
Derivative.
A what?
Derivative.
No.
Additive.
No. not geometric or arithmetic. What's it called? Oh, come on, somebody must remember its name. No, don't look, I want to see if you remember. I know you can read.
Oh, now I can read.
Recursive sequence. Recursive sequence, remember this? So, let's calculate some terms here. We have the quick way to do it on the calculator. Do you remember? We start with 2, and then we have 4 minus 3 over 2, and we get, for the next term, 5 over 2. We put 5 over 2 back in, and we get the next term, 14 over 5. And we can continue, and the limit looks like it's 3. Okay? But we can't be sure. Maybe it's like 3.01, and maybe it's not always going to be 3. Maybe sometimes the answer is something like 3.5. So we need a way to get the answer exactly. I want to do this again. I want you to notice something here. Let's start with 2 again.
How
Yep.
do you type in that formula in the calculator?
Do you have your calculator yet?
Finally.
Okay.
I received it.
Right. Watch and listen carefully.
Thank you.
2 equals AC. 4 minus 3 over answer. Now, when we press equals, we can generate the sequence. Yes? Now, this value and the next value, they're nearly the same, right? And this is nearly the same as this. Can you see there's not much of a difference? More similar, yeah. That's an important idea, that as it gets closer to the limit, the neighbours start to become closer in value. Do you understand? So the neighbouring terms become very similar as it gets close to the limit. And then when it reaches the limit, they become the same. So what you can do is you can change this into this formula. Because when it's near the limit, Tn and Tn minus 1 should be about the same. So this formula can help you find the limit. So one more time, when it's near the limit, the neighbours will be nearly the same and they will be equal to the limit, as we saw on the calculator. So let's solve this now. How can I solve this? What should I do first? Step 1?
Times x.
Times x. So I get x squared equals 4x minus 3. X squared minus 4x plus 3 equals 0. Quadratic with 2 roots. Minus 3 minus 1. So that means x equals 1 or 3. That means the limit equals 1 or 3. But you have to make a choice. Now, if you were to look at the first value, you can't know if the limit will be 1 or 3, because 2 could move to 3 or it could move to 1. It's exactly in the middle. You don't know which way it's going to go. So you're going to need your calculator to at least calculate T2. So what was T2? T2 would be 4 minus 3 over 2, which is 2.5. So what do we think it's moving to? It looks like it's heading towards 3 and not 1. So I reject this one and accept this one as the answer. Okay. Yep.
How did you change both Tn and Tn minus 1 to x? Are they different values?
Oh, dude, I'd like repeated myself 4 times now when I said that, so I'll say the 5th time, just for you. You weren't using your phone at the time, were you? Right, so, one more time for you. When a sequence approaches its limit, the neighbouring terms become very similar in value. And as it reaches the limit, they actually become the same value, and that value is the limit. So the neighbours will roughly be equal to each other and the limit as you move to the limit. Okay. Does anyone require it a 6th time? No?
Can you show me how to put that formula in the calculator once again?
Hey, right. 2 equals AC. 4 minus 3 over answer. 2nd term, 3rd term, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, and so on. Okay. Anything else? Can we go to the next example? Oh yeah, the question would be, find the limit of this. Okay. Yeah.
Okay, so during this class, how can I say that I reject less than 1 yes or no?
Yeah, you.
So I have to write in the answer sheet T2 is.
If what I would need to see is, I would need to see the student calculate a couple of terms, and then you could just, if you wanted to put an arrow here. Yeah. It's not a formal reason, but it's a good enough reason for this level. Okay. Yes.
Is it possible that they are both the limit?
No, it's not possible, because by the meaning of the word limit, it has to move to one of them. So there cannot be 2 limits, there has to be 1 limit. Now it is possible though that you can get the other limit by changing where you start. So for example here, now not always, just sometimes it's possible. So we'll have an example here. Delete. Sequence Tn. What did I say the first term was? 2. And my formula was 4 minus 3 over the previous term. So the next one was 2.5, 2.8, and what's the limit? 3. So we'll go up to say the 100 term, and you see I get the 3. I wanted to move towards 1. So what number could I use at the start to get it towards 1? Would not 1 though, because 1 would make it stick. And I can't use 0 because in the formula I divide. So what number could I use?
-1.
So give me a number.
-1.
-1, okay. -1. -1 made it move to 3 quicker. Try a different number.
0.5.
0.5, good. 0.5, you think this will bring you to 1? And it doesn't.
No.
What about something really close to 1? Like 0.999? That has to go to 1. To 3. Okay? So it seems to be impossible to get 1, with the exception of if you start at 1. Being the only exception. Yeah? 0.999999. Wait. There we go. The tree. Yep. So sometimes the second answer is actually impossible to reach no matter where you start. But I do think there are situations where if you change the first term, you can move to the other answer. This doesn't seem to be one of them though. Yeah. Okay, let's have a look at the next type now. Example. Tn equals minus 5n squared plus 8n plus 5 over minus 4n squared plus 2n, like this. Okay, did you write this down? So let's see what this sequence is doing. Continue? Yeah. So I'll type it up again. Here is n and here is t. This is the first term, and then this is second term, third, fourth, etc. And then here, using my formula, for example, t1 is minus 5 plus 8 plus 5 over minus 4 plus 2, which is some number. T2 is 5 times 2 squared plus, what's that, 16 plus 5 over minus 4 times 2 squared plus 4, which is some number. So rather than do this, let me just type it in Excel, see what we get. So the first formula is minus 5n squared plus 8n plus 5 over minus 4n squared plus 2n. So my first answer I get is 9. Then when I put in 2, I get this number, 3 is this, 4 is this, 5 is this. But let's skip down to a big number. So rather than going up one by one by one, let's just jump to 10. I get this number. What about T100? I get this. T1000? I'll get this. So maybe we start to have a feeling about what the limit might be. T1,000,000, the 1,000,000th term. So it's kind of looking pretty clear to me. What would you say the limit is?
1.
1 or 1.25? Let's do 1,000,000,000.
1.25.
Yes. So I think here the limit will be 1.25. But how can we check that exactly? Not this time. Not this time. Not for this problem. Does anyone know how to simplify this? Could do, but not factorize. The trick is to divide everything by n squared. So this would be 5, this would be 8 over n, this would be 5 over n squared, this would be minus 4, and this would be 2 over n. Now what happens when you make n very, very big? Does this change? No. What happens to this when n is very big? It's 0, it's very small. What happens to this? Very small. This stays the same, and this small. So the answer will be 5 over 4, 1.25. So this type of problem is actually easier than the previous one.
Could you just repeat what you just said over there?
This bit here? I divided every term by n squared. So it's like I put everything over n squared. So here the n squareds cancel. N cancels with a square. n squareds cancel, n cancels with a square. So I'm left with 5 plus 8 over n plus 5 over n squared minus 4 plus 2 over n. So I divided everything by n squared. Yeah? And then I imagine the n is very big, like infinity. 8 over n would be very small if this is very big. If it's infinity, then it will be 0. Likewise, 5 over infinity squared is also 0. Yeah? Yeah, is that okay?
Yeah, why we didn't use the one or so, doesn't start with no?
Which one? What do you mean? The
last-
previous.
No, the last thing you wrote.
This.
5 up to 12.
Yeah, this is the answer.
Oh,
Yeah. And this is just some rough work. Okay, can I scroll down? Yeah? Yeah? Okay, next one. Go on. Off the phone, come on. Right, next one. Thank you. I have a number like this. Let's say 2.121212, etc. And I want to write it as a rational number, as a fraction like this. How can I do that? That's what we're going to look at now.
You just put it in.
Yes, that's true, but we need to do it the long way. So, first thing you should do is break this into 2 plus 0.121212, etc. Then you should break it again into 2 plus 0.12 plus 0.0012 plus 0.000012, etc. So you're breaking it at every 1, 2. Then you should change them into fractions. 2 plus 12 over 100 plus 12 over 10,000 plus 12 over 1,000,000, like this. And then when you look at this, you realize this is a GP. The first term is 12 over 10, and what are we multiplying by each time? Not 10, not 100, 1 over 100. So, using our new formula, this is A over 1 minus R. That's 2 plus 12 over 10 over 1 minus 1 over 100. 2 plus 12 over 10 over, no calculators, 99 over 100. 2 plus, I multiply the top and the bottom by 100. So that would be 2 plus 100, what, yeah, mistake?
Why I 12 over 10?
This is the first term.
So it's 12 over 100.
Thank you. 12 over 100. That's better. $12 over 100, 99 over 100. 2 plus 12 over 99. 198 over 99 plus 12 over 99. 210 over 99. Hang on, no calculators. Now, I can see that 3 goes into both of them. So if I divide the top by 3, I get 70, and the bottom by 3, I get 33. Okay, what were you saying the answer is? Okay, let's check it. 70 divided by 33.
Yeah.
Yes. Okay. Right. Please write this one down.
Why can't we do the algebra?
The algebra way.
Like, put 2.12 equal to 0 x, and then times 100.
Say that again. Put.
And 2.12 equal to x, and then multiply x by 100.
Oh, yeah, I know which method you mean now. Yes, that is an interesting method, and I do like it. However, I don't know in the exam. Well, I suppose it actually is okay in the exam, because in the exam they don't say the method. But it usually comes up in the sequence and series question in the exam, and I think they figure this is how the students will do it. But yeah, we can have a look at that method, because that's it's a little bit quicker, that method. Yeah.
Should you go to the previous question after everyone?
Yes, I will. Yeah. Yes.
Can I add the answer instead of have to do all?
Yes, it's just I didn't want to use a calculator because reasons. Okay. Do you have this? Can I continue? Right. There is another way to do this which is worth seeing. If I scroll to the left. So the other way to do it is you say x equals 2.121212. Yes, this is the way to, and then you multiply both sides by 100. So then you get 100x equals 212.121212. Then you minus. So you do 100 minus x, which is 99x. Do you know what? I'm going to just write the 100x on the top so it looks a little bit neater. 100x on the top. 2.121212, etc. 100x would be 212.121212. And then we minus them. So here we get 99x. 212 minus 2, 210. And then 0.121212 minus 0.121212 is 0.00000. So you get x equals 210 over 99, which is 70 over 33. Yeah. So this is the algebra method. But like I said, they don't say, well, actually, no, I'm not 100% sure now that I think about it. They might say in the question, by using series, simplify this. I'll have to have a look at the exam question. If they didn't say you could do it this way, but they might say use the SN formula. I'll have a look at the exams to see. Okay. Now you need me to go back to the previous one. Yes.
Why is it 1.25 not 9? Oh, there's a minus.
There's a minus in the bottom as well. Okay. I'll let you try some questions now before the next lesson. So if you can do, I'll write this down. Homework 1 BCD, 2 BCD, 3 and 4 BCD.
Can you open the question?
Open what?
The question.
Which question? No, I'm closing it. Okay, maybe. I'll put it on the screen.